Alaska, the last frontier, is situated on the northern boundary of the Pacific Rim. Home to the highest mountains in North America, the geologically active mountain ranges of Alaska contain over 50 active volcanoes, shown here as red triangles. In the past 200 years, most of these fiery mountains have erupted at least once, at times ejecting hot gases and clouds of corrosive ash up to 10 miles into the atmosphere. Alaska is also a polar crossroads where aircraft traverse the Great Circle Airways among Asia, Europe, and North America, shown here in white. With more than 40,000 transpolar flights annually, volcanic eruptions and the resulting airborne ash pose a significant hazard to aviation safety in Alaska. This visualization study portrays two eruptions of Mount Redoubt, a 10,197-foot volcano near Anchorage, and the subsequent movement of clouds of airborne ash. The geographical region for this study is south-central Alaska. Features shown in the study area are Mount Redoubt, Mount McKinley, the Alaska Range, Cook Inlet, and the cities of Anchorage, Fairbanks, and Valdez. As the map view transforms into a three-dimensional landscape, our flight path begins over Valdez and travels northwest toward Anchorage. Passing over Anchorage, we bank to the left and turn southwest directly at Redoubt Volcano. The first eruption on the morning of December 15, 1989, begins at 3:48 a.m. and continues for 10 minutes. Our flight path approaches and then circles the ash cloud rising from Mount Redoubt. As we pass west and then south of the eruption, we observe the ash cloud rising to over 40,000 feet and beginning to move northeasterly on the prevailing winds. Over the next few hours, our flight path circles south of Mount Redoubt as the ash cloud clears away from the volcano and moves toward Anchorage. The animation combines the motion of the viewer with the time evolution of the ash cloud over a digital terrain model. The color of the terrain is set according to elevation. The colors were chosen to approximate ground cover during the fall in Alaska. The vertical scale of the terrain is exaggerated to better emphasize the topography. The ash cloud is rendered as an isosurface with the color approximating volcanic ash. The rendering obtained through this technique gives the viewer a visual effect showing the boundaries of the ash cloud. Details of the cloud shape are highlighted through lighting effects, and the resulting geometry can be manipulated interactively to view the ash cloud from any desired direction. The ash cloud isosurface is based on the output of a model developed by Hiroshi Tanaka of the Geophysical Institute with the University of Alaska and Tsukuba University, Japan. Using meteorological data and eruption parameters for input, the model predicts the density of volcanic ash particles in the atmosphere as a function of time. The three-dimensional Lagrangian form of the diffusion equation is employed to model particle diffusion, taking into account the size distribution of the ash particles and gravitational settling described by Stokes' law. By 9 a.m., almost 6 hours after the first eruption, we are heading north in the direction of Anchorage, and we can see the wide dispersion of the ash cloud which has passed over the Anchorage area. As we continue north past the volcano, a second, much larger eruption occurs at 10:15 a.m. and lasts for 40 minutes. At the time of the second eruption, Flight 867, a 747 jet with 227 passengers on board, was southbound at 33,000 feet, approximately 600 miles north of Anchorage. The flight path of this aircraft enters our view in the center of the screen behind the ash cloud at 11:20 a.m. Unaware of the eruption, which was hidden by clouds and invisible to radar, the jet proceeds on a collision course with the ash cloud. At 11:46 a.m., the jetliner enters the ash cloud about 100 miles north of Anchorage and loses power in all engines, as shown by the red color of the flight path as it emerges from the cloud. With the cockpit windows sandblasted by the ash, the jet glides for 8 minutes while the flight crew reverses course and attempts to restart the engine. Barely 7,000 feet above the ground, the engines are restarted and the jet is able to make an emergency landing in Anchorage at 12:25 p.m. The flight path of the jetliner is based on data obtained from the Federal Aviation Administration. The flight path is modeled using three-dimensional, time-dependent cubic splines. A similar technique is used to control the camera motion required for the flyby in this animation. As the animation draws to a close, we see the wide dispersion of the ash cloud nearly 12 hours after the first eruption. In the final view, the three-dimensional terrain is returned to a view from outer space, resembling what a satellite would see. In the final animation segment, we simulate the view from the cockpit of Flight 867 during the December 15th encounter with the Mount Redoubt ash cloud. The flight begins at 11:20 a.m., about 250 miles north of Anchorage, just after Mount Redoubt has erupted. The jetliner is flying south at 33,000 feet at a speed of more than 500 miles per hour. The ash cloud from Mount Redoubt, rising prominently in the center of the screen, was hidden by weather clouds and low light conditions during the actual encounter. As the jet enters the ash cloud at 11:46 a.m., the first sign of danger is a sudden blackening of all forward-facing cockpit windows. Blasted by rock and glass particles traveling at 500 miles per hour, the windows become opaque almost instantly. The crew, forced to navigate solely by instruments, banks the jet sharply to the left to reverse course in an attempt to avoid the ash. Seconds later, all four engines quit and the jetliner begins gliding toward the rugged Talkeetna Mountains below. Fighting to maintain control of the blinded and powerless jet, the crew is keenly aware of the 10,000-foot mountains below them. As the flight engineer repeatedly executes the engine restart sequence, the pilot banks right, then left again, searching for a way out of the ash and away from the mountains below. After 8 minutes of near panic, the crew succeeds in restarting the engines barely 7,000 feet above the ground. The animation comes to a close as the jet slows and makes its final approach for an emergency landing at Anchorage International Airport at 12:25 p.m. The flight path for this simulation is based on data obtained from the Federal Aviation Administration and is modeled using three-dimensional, time-dependent cubic splines. The same technique is used to control the camera motion in the eruption flyby in the first animation. Since 1989, 2 additional major eruptions of neighboring Mount Spur have disrupted the international air traffic of the Anchorage area. Recognizing the hazard to aviation safety in Alaska, the Alaska Volcano Observatory continues to improve techniques to predict the movement of volcanic ash in the atmosphere. The eruption visualization of Mount Redoubt volcano was produced in a collaborative effort by the University of Alaska Geophysical Institute and the Arctic Region Supercomputing Center.